All right, domain and range of functions. Find the domain of this function. Now, for square roots, I know that whatever that's inside the square root must be non-negative. It has to be 0 or greater. Okay? So what you need to do, you have to solve this by stating that what's inside the square root, which is x squared minus 5x minus 14, say that's 0 or greater. Now, solving inequality is harder than solving equality. So some of you know how to quickly solve this, and you guys are not confused at all. That's great. If you know any other method that you're used to, use that. Now, if you still have trouble solving inequality like this, please try to do the following method. First, solve the quadratic equation. Now, this can be solved if you factor it. You're looking for two numbers that multiply to negative 14 and add to negative 5. Okay. 14 factors as 7 times 2, and what do you know? 2 minus 7 gives you negative 5, right? So you know that negative 7 and positive 2 are the two numbers that will satisfy this, which means that this can be factored as x plus 2, x minus 7 equal to 0. And then when two things multiply to equal to 0, either the first factor is equal to 0 or the second factor is equal to 0. So you write down x plus 2 equal to 0 or x minus 7 equal to 0. This one, if you subtract 2 both sides, you get x equals to negative 2. This one, if you add 7 both sides, you get x equals to positive 7. So you quickly get the answer for the equation. Note, however, this is not the answer yet because we're trying to solve this inequality, not the equality. So we have a few more steps to go. However, I really want you to practice this so that going from here to there is like a snap, okay? If you're still struggling with solving this, you really need to work harder, okay? All right. So, what more do we have to do? Well, it's like the following. We have the number line, and we know that at negative 2 and at 7, these values make this inequality equal to 0. And since these are the only places this polynomial can be 0, in other places it's either positive or negative. Okay? And if you knew the graph of these polynomials, they can never change signs unless they go through a 0. So if it's positive on one point here, say, if you plug in 0 and you found out that it's negative or positive, then it will stay the same sign until it hits a 0. Okay? So a nice effective way of figuring this out is to pick sample points before and after. So I like to pick 0 for my sample point, and multiples of 10 is also another favorite number that I use. Okay, so I'll use positive 10 and also negative 10. These are my sample points. What I'm going to do is I'm going to plug in these numbers into this function and see what I get. Okay. So first, negative 10. Negative 10 squared minus 5 times negative 10 minus 14. Negative 10 squared is?
100.
Positive 100. Negative 5 times negative 10?
50.
Positive 50 minus 14. I don't care the exact value. I can just judge whether this is positive or negative. Is this positive or negative?
Positive.
It's positive. It's always already positive. So it's okay. Okay. Since we're looking for something that's positive, it's going to be good here. Okay. So put a check mark there. Okay. Now let's try the positive 10 one. Positive 10 one, all we have to do is this, right? Still 10 squared is 100. And 10 times 5, oh, this time it will be negative, right? Okay, 100 minus 15 is 50. 50 minus 14 is 36. It still works, so that's a good one. Okay. Now the only remaining thing is what? 0. So you plug in 0. 0 squared minus 5 times 0 minus 14. Well, that's 0, so you get negative 14, which is negative. Is that good? No good. We're looking for something that's positive, so that's a no-no. All right, so we figured out that it should be from negative infinity until negative 2 and 7 until infinity. So the answer would be domain is equal to negative infinity up till negative 2. And I need the square bracket because negative 2 is included. Whenever you have greater or equal means that 0 is okay. So negative 2 makes this left side 0 and it's okay, so I use a square bracket. And the second one is 7 until infinity. Again, I use square bracket because 7 is okay, and you union the two, and that's the answer for the domain.